Any questions over the homework assignment so far? Now, law of cosines is going to be a lot easier than the law of sines. Law of cosines is a little bit more accurate in what we deal with. We don't have the ambiguous case where we could have no solutions, one solution, or two solutions. And it's a little bit easier to work with. Now, with this here, we're either going to be given three sides or two sides and an angle. This is how these are going to work. Now, if we're given three sides and we're trying to find the angle, we're going to be using one of these forms here. If we're given two sides and an angle in the middle, we're going to be using one of the first three. Because when we talk about law of sines, and the main difference is, so we have A, B, C, little a, little c, little b, we had to have a side and an angle opposite. That's what we had to have to use law of sines. We had to have a side and angle opposite. Now, in any of these here, we don't need that. Because if I'm given these three here, side C, side B, and angle A, I can find side A. I couldn't do that with law of sines. Because if I wanted to find side A, I'd have to have angle A. I have to have one and the other. This we don't. So if we're trying to find an angle, first we're going to use, or one of the sides, we're going to use this here. If we're given three sides, we're going to use the other. So these three here are really looking for angle, and this here is really looking for sides. Now, for the most part, I don't necessarily put it in this form here to start with. I don't see why it makes a whole lot of sense. In that, for us to find angle A, B, or C, given one of these formulas, I'm going to have to apply the inverse function at some point. Because for me to find angle A, I'd have to take cosine inverse of both sides, really just telling me that A is equal to cosine inverse of b squared plus c squared minus a squared over 2bc. And the same is true for finding angle B and angle C. So when I look at this formula, especially for finding the angles with law of cosines, I just start off with A is equal to cosine inverse of this here. And for these here, we could really think of this, well, I'm going to have to square root both sides. So A is really equal to the square root of b squared plus c squared minus 2bc cosine of A. I think of them more in these here than just as the normal formula, because that's what we're going to have to do anyways. And when we apply the square root to both sides, we normally add the plus or minus. Well, here we're not on a coordinate plane, and we're talking about the length of a side. So it has to be positive. So we don't add the plus or minus there. Questions on this so far? Not too bad. So when we look at this here, we're trying to find a missing angle. Because they're given three side lengths. A is 8, B is 19, and C is 14. We're given three sides, we need to find the angles. And if we tried to use law of sines, so you don't have to write this down. So sine of A over 8 is equal to sine of B over 19 is equal to sine of C over 14. Because if we try to set it up this way, we need only one variable. And no matter how I set it up with A and B or A and C or B and C, I still have two variables. Because I have angle A, B, and C. I have three unknowns. I can only solve for one at a time. So the law of sines does not work. But we can use law of cosines. Because we can write it in one of two ways. We could say that cosine of A is equal to b squared plus c squared minus a squared over 2bc. Or we can use the other version saying that A is equal to cosine inverse of b squared plus c squared minus a squared over 2bc. And I just picked A at random. Because we're going to have to find the values of A, B, and C anyways, so I just picked A to start with. We could have started with angle B or angle C. It really doesn't matter which. We just need to pick one. Any questions on this so far? we just need to plug in. Well, b in our case is 19, so we have 19 squared plus c is 14 squared minus 8 squared over 2 times 19 times 14. Plug it in. Let me say cosine inverse of fraction 19 squared plus 14 squared minus 8 squared over times 19, 14. $22.07. We agree with that. We could round to the second decimal place, so 22.08 degrees. And that's it. Questions on this here? Questions on anything we've done so far? Well, now we can move on to angle B. Because B is equal to cosine inverse of a squared, so 8 squared, plus c squared, which is our 14 squared, minus b squared, which is our 19 squared, over 2 times 8 times 14. So the really only thing that changed from the previous one is that the 19 and the 8 change places, yes? And y'all get 116.80, or 0.8 rounded to the nearest decimal, 2 decimal places. Well, what do we know about any 3 angles in a triangle? You have to add together to be 180, yes? So we could add these 2 angles together and subtract it from 180. So we can say 116.8 plus 22.08, 138.86, and 80. 8, 6, 4, 1, 1. 41.14 degrees. I think what y'all got, unless I did my calculations wrong. 12, yes. Transpose an 8 as a 6. So C is our 14. So if we wanted to, in the calculator, have plugged it in, we do get the same value. Now we could have used law of sines, and a lot of books will do that. They'll find the first angle or first side, and then go back to law of sines to find the other. And for this here, I believe the book would actually agree with us, or do it the, well, not agree, would do it the same way. Because it's not so much about agreeing and disagreeing, it's just which method you want to use. Would have done this by law of cosines. The ones where we have 2 sides at an angle, a lot of times it'll revert back to law of sines and do it that way, which is fine. But as we saw already, law of sines, there are some discrepancies where we can get different values depending on the setup of how the triangle is. So law of cosine still works. We just have to find the other side. Any questions on this here? Now, what do we think of finding the missing angle so far? Not too bad. The formulas are actually quite easy to remember. There is a connection between the side angle that we're solving for and the side opposite. Because if we look at A, find the angle A, which side is being subtracted? A, yes? Every other place, the two positive on top are B and C. The two on bottom are B and C, yes? If we solve for angle B, the one being subtracted on top is side B. A and C are positive. The two sides on bottom are A and C. And if we're looking for angle C, the one being subtracted is side C. The two sides that are positive on top are A and B. On bottom is A and B. That's kind of how I keep it straight. You don't have to. You will be able to have the formulas. So that's it. Questions on finding the missing angles? I think we feel pretty comfortable with this here, yes? Because law of cosines, similar to law of sines, we're just plugging the information in. Now the other one that we can have is find the missing angles and sides, and we're given this setup here. So we can say A, B, C. A is 25 degrees. Side length B is 9 meters. Side length C is 12. So even if we try to approach this with law of sines, because we need another side or angle, so we could say side A over sine of 25 is equal to side length B over sine of B is equal to 12 over sine of C. And no matter which two of these fractions we pick to solve for, we'll still have two things we have to solve for. There's no way we could set this up with law of sines and only have one variable. We'll always have two. So this here doesn't work. But we can solve this with law of cosines. And the only side that's missing is A. So we can say A squared is equal to B squared plus C squared minus 2BC cosine of A. And for us here, A is the value we don't know. We know B is 9, C is 12, minus 2 times 9 times 12, cosine of 25. Now at this point here, we could type this in, but I would wait, because what we can do is square root both sides, showing us A is equal to the square root of 9 squared plus 12 squared, minus 2 times 9 times 12, cosine of 25. We can round to the nearest second decimal place, and if we type this in, we get questions on this here. All right with this so far? Now at this place, some books, and I've seen it used in different places, would go back to law of sines. Because now we do have an angle and a side opposite, so we could use that to find the other angle, which is fine. There's nothing wrong with that. And I think I haven't looked too deeply at the book to see what they did for this one, I would go back to law of cosines. Because with law of cosines, it's guaranteed to work, and we don't have the different cases. And we already know, so say angle B is equal to cosine inverse of A squared plus it's not A. A is our 5.41. A squared plus C squared is our 12 squared minus B squared over 2 times A times C. And for the most part, I feel like typing this in is a little bit quicker, a little bit easier than doing our law of sines. If you want, we can put parentheses around these. And say cosine inverse of 0.41 squared plus 12 squared minus 9 squared over 2 times 5.41 times 12, 44.71 degrees. So we found that. We found side length A is our 5.41. Now we just need to find angle C, yes? Two ways we can do it. One, we can use law of cosines again to find it. Or we know that any three angles in a triangle have to add together to be 180. So we can say 44.71 plus 25, 4 and 9, and we can subtract it from 180, 9, 2, 0. I think we get 10 point, nope, 110.29. Questions on this here? Not too bad. We like law of cosines better than law of sines. I don't think we need to see another example one of these. The other one, the other type of area formula we can use is Heron's formula. To find the area of a triangle, we take the square root of S times S minus A times S minus B times S minus C. And S, the value of S, is the three side lengths added together divided by 2. And I will tell you this for sure, S is going to be bigger than the values of A, B, and C. S is always going to be bigger than the values of A, B, and C. Because if we add them together and take half, that should be bigger than any of the individual ones. So if we look at this first one here, they told us the side lengths are 43, 53, and 72. So to find the area, which is the square root of S times S minus A times S minus B times S minus C, well, we already have half of it. So we don't have what S is, but we do have A is 43, B is 53, and C is 72. So we just need to find the value of S. And S is equal to A plus B plus C. So 43 plus 72 plus 53 over 2. 43, 53, 72. 43 plus 53 plus 72 all over 2, which is 84. Bless you. Questions on this so far? I mean, we could try to do this by hand. Plug it in. Square root 84 times 84 minus 43 times 84 minus 53. 84 minus 72. And again, we can round to 2 decimal places, so the area of this is 1,131.89. And since they gave us the units, we could say meters squared. Questions on this here? Now, the only way that the area ones will get tricky is if they don't give us 3 sides. If they gave us 2 sides and an angle in the middle. And we have to use law of cosines to find the third side, then we can use the formula. But that's it. Questions on this here?